Aloha students, how are we doing today? We just have a couple of more days of content, and then we'll be doing a little bit of just an activity. You'll do an activity that you'll make some decisions about the content you've been presented. How's that sound? So I know that's kind of cryptic, but that will be next week. So not too much content left, and then we'll do a couple of end of the course things next week. All right, everybody, here we go. Okay, today's topic is something very interesting. It's called the scientific revolution. The scientific revolution goes hand in hand with this idea of the Renaissance. The Renaissance, the Reformation, the scientific revolution, the age of exploration, all these things all happened at the same time. And these famous men we're going to hear about today, they're all alive at the same time as Columbus and Michelangelo and Leonardo and Raphael and Martin Luther and King Henry. They're all these guys are all alive at the same time. It's quite a remarkable moment in history. So what I'm basically making a reference to here is the Middle Ages up until the year 1500, which is sort of what we sort of say is the end of the Middle Ages. Comes to an end in 1492. So people in Europe lived the same way. They were all Roman Catholics. Everybody believed in God. Everybody is a serious Christian. Christianity was very important. It's the one thing everybody had in common, regardless of what language they spoke, regardless of where they lived, regardless of it was Southern Europe, Northern Europe, everybody was a Roman Catholic. All right? And because people were devout Roman Catholics, there was belief that God was involved. God was omnipotent. He was busy. He was doing stuff all the time. He was involved in your life. He was involved in my life. He was involved in that person's life over there. God was a busy thing, but God could do it because God was so all-powerful. And people believed in God doing things like miracles. And people believed in, people were very superstitious, and people believed in myths. And part of this is coming out of the Middle Ages. Not very many people in the Middle Ages. There was a lack of education. That was not necessarily something that was emphasized during the Middle Ages in Europe was education. Remember I told you about the Chartres Gothic Cathedral and how they had to do stained glass windows of the stained glass windows in Chartres Cathedral. Gothic Cathedral are the stations. Basically, they're the Old Testament Bible story, but they're done in pictures. Why did the Roman Catholic Church have to do it in pictures? Because most people could not read. Okay, so don't come home too late and cross the bridge, or you have to cross the bridge to get home. Don't do it too late, or the troll will come out and get you if you come home too late. Okay, and this blind acceptance to these things was the norm. You didn't question things. You didn't question the Roman Catholic Church. You didn't remember the feudal pyramid, everyone. You didn't question the feudal system. All right, and then what we basically have is we have three very famous scientists come along, 1, 2, 3, sort of, if you will, all from three different places, places in Europe. Three of the most, what are always considered, you see these lists of the most influential people of all of history. These three guys are always on it. Okay, so I bet you've heard of two of them. I bet you haven't heard of the first one. The first one is a guy named Nicholas Copernicus. Okay, Nicholas Copernicus was a Polish astronomer. In other words, he was from Poland. He was from northern Eastern Europe. I believe Poland has its own currency still, but if they don't and they're on the euro, their currency used to have whatever particular was one of their bills had Copernicus's picture on it. So you can see he's 19 years old when Columbus sails. How's that sound? Okay, and Copernicus was the one we mostly associate in modern times with this revival of the sun-centered universe theory. Okay, so what I'm getting at here is these guys are trying to convince people who believe of things like the earth is flat, the earth is the center of the universe. These guys have this job, things that we all just take for granted today. These guys took it upon themselves to try to change people's minds about this thing because of the things they studied. They were studying, okay? Helio, sun. Remember how we make Greek words, heliocentrism, I guess? The theory of the sun at the center of the universe. Most people believed in the geocentric theory. So what do you study when you study geography? Oh, geography, there we go. You study the Earth. So the old theory of the Earth being the center of the universe. He also stated that the Earth rotates on an axis. Okay, so this is like really crazy. This is something that a lot of people struggled with because everybody used to believe that the Earth stood still at the center of the universe. He's not, so you got to understand what I'm getting at. He's not only just saying that the Earth is moving around the sun, it's also spinning as it's moving around the sun. So this is very difficult for people to really grasp or to even comprehend could be possible. It's spinning and revolving around the sun as it does so. All right. He thought that the revolutions of the planets, including the Earth, were circular. All right. He thought the planets revolved around the sun in circular orbits. The story goes that in 1543, his friends were trying to convince him trying to convince him for years to write a book, and he doesn't do so until very late in his life. And the story goes that the very first book off of the printing press was handed to him on his deathbed, and he was at least able to see that. And one of the person that read his book was this man, Galileo Galilei. He was from Italy, and you can see he's born 21 years after Copernicus dies, but he's super influential on Copernicus. This guy lives in Italy. That's going to be a very important part of this whole story. He's the first major scientist. This is something you might find interesting. He uses a telescope. He doesn't invent the telescope, but he is the first one to sort of use a telescope on a massive scale. And what does this tell us about Copernicus, by the way? Copernicus did not use a telescope, so that's pretty amazing to sort of think about the fact that Copernicus did all of his work, basically being a night owl, working the graveyard shift, I guess you could say. And one of the things we associate with Galileo, what did he really look at? One of the things he looked at were the moons of Jupiter. Okay? Guess what the moons of Jupiter are doing? They're revolving around Jupiter. What are they not revolving around? They are not revolving around Earth. So right there you have automatic proof that the geocentric theory is not true, is not factual, because of this exact thing, the moons of Jupiter. And I think I should have looked this up, but I think Jupiter has maybe 10 plus moons, and his telescope was strong enough to see 4 or 5 of the moons. All right. He believed. Okay, now this. Let's see if you've heard of this. This is one of his other theories. He believed that all objects, regardless of weight, will fall at the same velocity. Right now, what does that mean? That means that he's studying. What he's really studying right there is gravity. Right. He's interested in the study of gravity. And so what he's arguing here is that most people would say, well, you got 2 different things of 2 different weights. If you were to drop them, well, the heavier thing would fall faster. And he said no. He said they'll fall at the same velocity because the mass of the Earth and thus the gravity of the Earth is greater than the masses of the 2 things you're dropping. So the gravity of the Earth will pull those things down at the same speed. To prove this, maybe you're familiar, this is what I'm talking about, maybe you're familiar with this, he does a famous experiment to try to prove this true at one of the most famous buildings of all. This building, maybe you've heard of. It is called you know what I'm talking about, everyone? This famous experiment where he did drop 2 things from a height that were different weights. He did it from the Leaning Tower of Pisa. All right, the Leaning Tower of Pisa. Have you ever seen this building? I'm sure you have. All right, here we go. And this is a bell tower at a church in the Italian city of Pisa, P-I-S-A. And it's really a remarkable building. It's defied physics. It started to lean almost as soon as they got it to the height they got it. So they're basically almost finished with the building of this thing, built during the Middle Ages. And it already stood, the foundation was bad. So it was already starting to lean right away. And you can see that on this photograph has been drawn 2 lines, and this is to symbolize where Galileo, and I'm not sure if it was him himself or one of his assistants, actually went up to this spot and dropped. Now, the tower has got cables over here today. They've tried to reinforce it over here to try to make sure that the thing doesn't fall. It's, like I said, it's defied physics. It probably should have fallen a long time ago, but they seem to have it. It's a very popular tourist attraction, as you might imagine. Okay, so the Leaning Tower of Pisa, and that is what he is really, that might be what he's really well known for, is that experiment more than anything else. Now, here's what's sort of interesting, is that the Roman Catholic Church, he got in trouble, and he was friends with the Pope. He was, Galileo was actually a very devout and pious practicing Roman Catholic himself, and he was friends with the Pope, but then he started to talk about heliocentrism, and the Roman Catholic Church really wasn't ready to go there yet, and so they put him on trial, and he was found guilty of speaking out against, basically being a heretic. Remember Martin Luther? He's basically convicted of heresy, talking about heliocentrism. Now, you know, this is, a lot of people in history make a big deal out of this story. This is just like the old Socrates trial. Smart people are being put down by religious people. It's not quite as bad as that. He was under house arrest for his rest of his life in apparently a very nice house, and like I said, he was a practicing Catholic his whole life. He had actually been sponsored. Much of his studies had been previous, in early parts of his life, much of his studies had been sponsored by the Roman Catholic Church. So everybody likes to make a big deal out of this. You know, there has always been a tug of war between, faith and fact, religion and science. But he was found guilty and had to take back what he said publicly, and he did do that. Here's the third guy. His name was Newton. I'm sure you've heard of him. Sir Isaac Newton. Isaac Newton is considered, again, those lists, sometimes those lists of the most important people of all of history. This guy is usually on it. He was born in Britain, and you can see that he was born in the exact year that Galileo died. Newton is the one with the apple tree story, and so some people say, well, he was sitting under an apple tree and either the apple fell and hit him on the head, or he just happened to be looking at an apple up hanging on the tree, and at that exact instant he was looking at it, it happened to, it was ripe and fell, and he noticed that it fell in a straight line, and he sort of thought, well, if I continued that straight line, it would go straight to the center of the earth. And so he's the one we associate with the 3 laws of gravity. One of the most important things, however, I would say, though, is that well, he's pretty smart, right? He invents calculus. Did you know that? He invented calculus when he was 24 years old. Now, why is this so significant? This is significant because what do scientists need to prove their theories? They need math. They need math. Math can make a theory into a fact, because the calculation works out every single time. How's that sound? That's what my way of putting it. So that may be something that we should think about more than anything else. He did most of his work in gravitation, like I said. He's the most influential scientist of all time, without a doubt. His 3 laws of gravity, the most famous one is, for every action there is an equal but opposite reaction. All right, so that's what we should sort of think of when we think of Sir Isaac Newton. What is the importance of the scientific revolution? Well, this is a huge change in the way people think. This is, shall we say, really, here's the best way for me to put this to you, is that these scientists and many others prove basically several things. That the laws of nature are unchangeable. They are predictable. You should be able to predict things in nature. All right, now this is what I always sort of say. Hear me out on this one. Take a chair in your house and put it in front of a window that faces east, so you can see out to the horizon to the east. And what I want you to do is I want you to nail that chair to the ground. Tomorrow, you just be about an arm's length away from the window. Tomorrow morning, I want you to wake up and I want you to watch the sunrise, and take a Sharpie and put a little line on the window where you see the sunrise. All right? Nail this chair to the floor so the chair cannot move. Then 364 days from now, on the exact same day a year from now, guess what you would be able to predict should happen the morning of the sunrise? Well, you should be able to predict that the sunrise will occur right on that same little line, a Sharpie line on your window as the year previously. Now, during the rest of the year, the sunrise will move from that spot, but you should be able to predict, and the fact of the matter is that's exactly what will happen. Okay, so therefore, if the nature is predictable, the universe is now observed to act almost machine-like. All right, and the point is, when we think of machines, why do humans make machines? So the humans don't have to do the work. So if the universe is acting like a machine, what does that say about God's role? Do you remember back up here what I said when I started this thing off? God was involved in all things. He was a busy man. He was a busy person, shall we say. Well, if the universe is machine-like, what does that make God? That makes God an observer. He's not busy. He's not doing something every second. He's not involved in your life every minute. He's not involved in my life every minute. The human body, we could talk about, if we got into the scientific revolution even more so, we could get into the whole discussion about how scientists who are studying the human body acts like a machine, was the same sort of argument. All right. Now, if God is an observer, what does that do to his role? Well, I would argue it decreases his role. And if God's role is decreased and dare I say, less significant in everyday life, God's representative on earth, the Roman Catholic Church, is also going to be, their role is going to be decreased. Now you can see, and we sort of talked about, when we talked about back in the days of Aristotle being one of the first ones to sort of talk about the earth moving, who defended Aristotle the most? The Roman Catholic Church. So this was the threat, that their role would be decreased if the universe is machine-like. Okay, now just a couple other things let me just say here. Number 5. There's a couple things we should understand about these three guys, and that is they were all wrong about something. They were not perfect. They were certainly, I would argue, some of the smartest people ever, but they were not perfect. Their science, some of their science was proved wrong. For example, Copernicus, the sun is not, he was a heliocentrist. He thought the sun was the center of the universe. Okay, that's not correct. The planets don't move in circles, they move in elliptical orbits. Now, should we say, well, Copernicus was an idiot? No, not at all. I think Copernicus is one of the smartest people of all time. But let's make sure we understand here, is science always unquestionable? No. This is the argument I'm making. Dare I say Galileo was wrong. As a matter of fact, in that experiment from the Leaning Tower of Pisa, guess what? The heavier thing did hit the ground first. It actually, it's difficult to see with the naked eye, but in fact, his experiment only works in a vacuum. Okay, so the heavier object will fall through the atmosphere, when there's atmosphere, a little bit faster. Dare I say Newton was wrong. Here's the smartest human being ever. I think that's legitimate to say. Newton was wrong. So one of the arguments he made is that when there's a gravitational pull between two heavenly bodies, they will move towards each other. Well, guess what we've observed in modern times? We've observed heavenly bodies moving away from each other. This is why people believe in something called the Big Bang, because scientists can look through telescopes and they can see two heavenly bodies, and they should say to themselves, well, they should be moving closer to each other. Well, they come back after some amount of time and they realize they're further apart. Well, that's because they are still reacting from the Big Bang. The force of the Big Bang is still forcing those things to move away from each other. And so, I think here's an old article from a magazine called Scientific American. Was Einstein wrong? Well, a lot of us think of sort of, Einstein being the other smartest person to ever have lived, and probably I think that's legitimate to say that. But is science always perfect? No. And when somebody says you can't question the science, I would argue that's not very scientific. So science I love science, by the way. I think science. I think science is great. I love science. But let's make sure we understand. Be very careful when somebody says to you, "The science proves it beyond a shadow of a doubt." That's not very scientific, because even the smartest guys of all were wrong. So now let's do one more, and this will be the last one, number 6. And my little question for you going forward is, what nations of Europe do you think were the places where the scientific revolution thrived the most? What nation? So think about this. I'm asking you, what European nation do you think that science was actually allowed to thrive the most? Now, you could think of a specific place, but I think of several specific country. I think of several countries. So here's my answer. Science thrived especially in Protestant countries. Now, what am I getting at here? Remember now, Martin Luther, Germany. Henry VIII, England. They were the 2 leading nations of the Protestant Reformation. Where is Newton from? Newton is from England. Okay? What do Protestants and scientists, what do they have in common? They have in common that they are going against the will of the Roman Catholic Church. So therefore, and by the way, what did I tell you about Galileo? Galileo was the guy, right? Galileo was the guy who got in trouble. Here we go. Galileo, he had to take back what he said publicly. You remember where I said Galileo was from? Italy. Where's the Roman Catholic Church headquartered? Italy. Okay, so this is my little argument here at the end, is that if you wanted to be a scientist and really take off, a Protestant country was probably a better place to do it from. Okay, everybody? The scientific revolution, a very important moment in history. 3 of the most important guys you could probably think of. Copernicus, Galileo, and Newton. All right, everybody, that's it. Hope you enjoyed that. Hope you learned something. Hope you thought about a couple things there. We'll be looking forward to talking to you the next time. Aloha.